Okay, what would you like?
Precalculus, Chapter 2B, Day 2, notes. We're going to be solving rational equations, which are equations that have algebraic expressions in the denominator. So there's a little bit of a change for us. We're going to add this to our toolbox of things that we can algebraically solve. So here are your helpful hints, steps, whatever you would like to refer to them as. First off, when they give us fractions, we want to clear the denominators so that there are no more fractions. Okay, that's step one. Step one is to clear all the denominators. So for example, if we had a question back in grade school, like 2/3 plus 5, 6 minus 1/5. Okay, and we had to combine these three terms. Right? Remember what we had to do back then? You had to find common denominators. Well, common denominators, you would have to find the factors, for example, of 6, which would be 2 times 3. And then if you have this 3 and this 5, and then you got a 2 and a 3, so the 2 is different. So you would say that between 3, 5, and 6, your lowest common multiple, okay, which is going to be your least common denominator, is going to be 3 times 2 times 5, which is 30. Okay? 3 is a multiple of, 3 is a factor of 30, 6 is a factor of 30, and 5 is a factor also of 30. So we're going to be doing basically the same thing here as we solve these equations. Right? So let's take a look at this. So number one says we're going to multiply each side of the equation by the least common denominator, which is going to be your lowest common multiple of all the denominators. Okay? Yeah, which is exactly what it says. Good. You may need to factor. Like we factored the 6 down to 2 times 3. We got the prime factors. We're going to factor this first guy right here because there's a quadratic in it. So actually, before we look at steps 2, 3, and 4, let's factor this guy right here. This guy is actually x, because there's a GCF of x times x minus 4. Okay. All right. So we may have to factor. We just did. Now, after we do the multiplying, we're going to isolate a variable, which is your solving. And then we're going to have to remember that denominators can't equal 0. So there may be some extraneous solutions here. Okay. So for example, if you have 5 over x and you end up with x equals a bunch of possible answers and one of those possible answers is 0, you say, well, x can't be 0 because you can't divide by 0. There can be no 0 in the denominator. So that means that 0 in this case would be an extraneous solution. Okay, well, that just means we're going to have to go back and check our answer. Check our answer by making sure we don't have any zeros in the denominators. And then, when we're all said and done, we can use our graphing calculator and we can graph it and check it. So, as it says, I like to set one side equal to 0 and then just find the x-intercepts or the zeros, okay? Now, if you don't want to do that one step or, sometimes there's 2 steps of algebra, then you can type the left side into y1, you can type the right side into y2, and you can use the intersect function of your calculator. Okay, so let's look at question 1. Let's see if we can solve for x here. So step 1, we're going to multiply both sides of the equal sign by our LCD, which is going to be your lowest common multiple of your denominators. So what are the denominators? Well, I'm going to make a little list here. Okay, my denominators are, we got x, we've got x minus 4, and we've got x squared minus 4x, but we have already factored that, so we know that that is x times x minus 4. So I'm looking at these three denominators, and I want the smallest algebraic expression that I could get to cancel all three of these denominators. Well, if I take x times x minus 4, then the x would cancel and the x minus 4 would cancel. And also x minus 4 times x is going to cancel. So this guy right here is my LCD. Okay? So my LCD is going to be x times x minus 4. All right, so I'm going to multiply all three of these fractions, all three separate terms, by this LCD. So x times x minus 4, and multiply that by the first guy. And I'm also going to multiply it by the second guy. And then I'm going to multiply it by, let's go with red again, by the third guy. Okay. All right, now the equal sign was in here. So I'm going to keep the equal sign there, separating my two sides. Okay, so let's start off with the orange term here. Right? When I multiply the first term, x plus 4 over x, by my LCD, what happens? Well, the x cancels with the x, leaving me with x minus 4 times x plus 4. Okay? So I'm going to write that, x minus 4 times x plus 4. I'm going to bring down the plus. Now I'm going to take the green guys here. I multiply 3 over x minus 4 by x times x minus 4. Well, the x minus 4s are going to cancel. That leaves me with x times 3. So x times 3, or 3 times x, which is 3x. Keep my equal sign. Now, if I have my x squared minus 4x in the denominator of the red term, remember that that's x times x minus 4. That means that the x's will cancel and the x minus 4s will cancel. Okay? So I have multiplied all three terms by the same LCD, okay? And when I multiply that, the denominator cancels, so I just got negative 16. Okay? So now what have we here? We have a nice algebraic equation with no fractions. That was our goal. We've cleared all the denominators by multiplying by the lowest common multiple of the denominators, which is your lowest common denominator. All right, so let's take a look at solving this, which I'm pretty sure we can all do right now. First thing we're going to do is take care of these parentheses. We're going to FOIL this guy here. So we got x minus 4 times x plus 4, difference of two perfect squares. It's going to be x squared minus 16, because you're going to have x squared plus 4x minus 4x minus 16. Bring down plus 3x. Bring over your minus 16. Okay. Now, if there's one thing we remember or hope from getting to a point in 2a to solve using quadratic or factoring or just solving, we know that we want 0 on one side. So I'm going to add 16 to both sides of my equation. And I've got x squared. These cancel. Plus 3x equals, the reason we did this is so that would be 0. Cool beans. All right. So now you could quadratic this, but to me that's more trouble than it's worth. I'm going to factor. Remember, when we factor, the first thing we always do is find a GCF, a greatest common factor. So for these two terms, it would just be x. I'm going to factor x out of each of those terms. So I'm going to get x for the first term and plus 3 for the second term. Okay. Now I know that x could be 0. X plus 3 could be 0. So I'm going to subtract 3 from both sides. And I'm going to get x is negative 3. Cool. So what have we done up here? Let's look at our steps. Our steps have told us we're going to multiply by the LCD. Done. Steps told us we're going to isolate the variable. That's what we just did. Okay. Eliminate any extraneous solutions. So I'm going to just erase this top part here. Okay. So looking at these three fractions, the denominators are x, x minus 4, and x squared minus 4x. So what can x not be? Well, because of this guy, x can't be 0. Okay? Because of this guy, x can't be 4, because x minus 4 can't be 0. Okay? And then the x squared minus 4x is just a combination of both of them, where 0 and 4 both don't work. So what is the verdict? The verdict is that this solution of x equals 0 doesn't work. It's extraneous. So this one is not a correct solution. So x equals negative 3 is, according to our algebra, the only solution that works. Okay, so we looked at number 3 up there. So now we're going to check our solution with the graphing calculator. Okay, so we're going to go to Desmos and put this in. Okay, so take a look here at Desmos. I have typed into my top line here, x plus 4 over x plus 3 over x minus 4 plus 16 over x squared minus 4x. Okay, now notice what I did. It was equals negative 16 over x squared minus 4x. I put it over on one side of the equation, so I added 16 over x squared minus 4x. Okay, notice that's what I did. Right? So if I graph this, I'm just looking for zeros. Well, looky right here. You see that 0 is not a 0, but you see that negative 3 is. Okay? So if we go back and we want to graph this by hand, we can say that we had something that looked like this. It did not go through 0, 0, but it did go through negative 3, 0. And then we had this guy here. Okay. So it looked like we had a little asymptote here because x could not equal 4. And then we had, we also have an asymptote in here, but we aren't up there yet. So, okay, so that is going through these 4 steps and verifying that we are correct, because that right there tells me that my negative 3 was good. So let's try this with question number 2. Okay. So question number 2, step 1, we need our LCD. So I'm going to list my denominators. We've got a 2x, we've got an x, and we got an x minus 1. Okay. So we're looking at these denominators. All right. Now, the only thing I'm going to make note of here that's a little bit tricky, maybe you're thinking, wait, this is not tricky. This is exactly what I think. 2x, I'm just going to write as 2 times x. Okay, so we got the 2 and the x. What are my unique factors in the denominator? Well, this one has a 2, and there's an x. There's another x, but we've already got an x, so I'm not worried about the x. And then we got x minus 1. So that means my LCD is going to be 2 times x times x minus 1. Now, you make sure that it's your LCD, because if you say 2x times x minus 1, you're going to get cubics out of there. And that's going to be a little more difficult. You're going to be able to graph it on your calculator, but you may have a little bit of trouble doing the part that we have to do here, which is going to be most of the credit for a question like this. Okay, so we're going to multiply every single one of these terms by 2 times x minus 1. All right, so let's just make this a little bit bigger. All right, so now I'm giving myself a little bit of room to write. So we're going to multiply the first term, the gray term, by 2 times x minus 1. And multiply the blue term times 2 times x minus 1. And we're going to multiply the green term by 2 times x minus 1. Okay, so what happens when we multiply the gray term? The 2's cancel, the x's cancel, and we're left with x minus 1 times 1. I'm just going to leave the 1 out. We don't need the 1. Okay. For the blue one, if I multiply 5 over x by my LCD, the x cancels the x. So I'm left with 5 times 2 times x minus 1. For the green one, when I multiply by x minus 2 times x minus 1, the x minus 1's cancel, leaving me with 3 times 2 times x. Okay. So let's simplify these. Let's get this right here simplified up. So x minus 1 plus 5 times 2 is 10. 10 times x minus 1. Okay, so that's 10. See if I can write a little neater. So 10 times x minus 1 is 10x minus 10. Multiply the 10 by the x, multiply the 10 by the minus 1. Okay. Equals 3 times 2 times x. That's 6x. Okay, well, this isn't too bad at all here. Combine like terms on the left. Let's combine our x's. We get 11x. Let's combine our constants. Minus 11. Okay, do this a couple of ways. I'm going to do what probably few of you would do, and that is subtract 11x. I don't worry about the negatives. Okay, so I got negative 11 equals 6x minus 11x is negative 5x. Okay, now I'm going to divide both sides. Negative 5 divided by negative 5. So I get x. Negative divided by negative is positive. I got positive 11/5. Okay, if you want to make that a decimal, 2.2 or 11/5. Okay, so now I'm going to go back and I'm going to look at my denominators. Is 2.2 a denominator that I cannot have? No, because when does 2x equal 0? Well, that's when x equals 0, so that means x can't be 0. When does x equal 0? When x is 0, so x can't be 0. And then we've already taken care of the first two. When does x minus 1 equal 0? Well, that's when x equals 1. So I know that x can't be 0 or 1, but it can be 2.2. There's nothing wrong with 2.2. So I'm going to go with this, and I'm going to graph it. So let's go back to Desmos, turn off number 1 graph. Let's look at number 2 graph. Okay. Now again, I took the equals 3 over x minus 1 and just did minus 3 over x minus 1. I'm going to look for zeros. Okay. All right. So check this out. There's only one. That's right there. And it's 2.2. Isn't that awesome? Okay. So if I go out further, I'm going to find that like this side over here to the right, it's above 0. And it's going to come really close, but it's never going to quite get there, even if Desmos does round it. This side comes from below, and if I go to the left, the y coordinate's going to get really close to 0, but not quite, right? Even if Desmos rounds it, it's not there. And then in between, you got this part up here, but there's definitely no 0 up there, okay? So the graph backs up our 2.2. All right, so if we want to sketch our graph, let's see, we had a little tail down there, and then we had a tail here, and then it went up, and it was real close. And then there was a little dude in the middle up here too. Okay, all right, and the 0 that we had was at 2.2. Okay, 2.2 comma 0 was on our graph. All right, let's look at question number 3. Okay. A little more complicated, not too bad here. Step 1, let's find our LCD so we can clear those fractions out of there. Okay, so we're going to look at the denominators. We've got x minus 1, we've got x minus 2, and then we get this guy. There's an x squared. We've got a factor. Okay, so x squared minus 3x plus 2, because that's a 1, I can do product sum. Okay. Product is positive 2. They got to add up to negative 3. So negative 1 times negative 2 is positive 2, which is what we want. Negative 1 plus negative 2 is negative 3, which is what we want. So we got x minus 1 times x minus 2, which is kind of nice. So if I want to cancel all of those denominators, I need the lowest common multiple of these 3 factors. Well, I got x minus 1, I got x minus 2, and then x minus 1 times x minus 2. So I would say that this guy right here is going to be my LCD. Okay, so my LCD, which will cancel all of these out, is x minus 1 times x minus 2. So let's go ahead and multiply these guys. So let's take this first one, multiply by x minus 1 is x minus 2. So the x minus 1s will cancel, leaving me with 4x times x minus 2. Okay. This middle guy here, again, we're going to multiply by the LCD. We can multiply every individual term by the same constant, and in this case, the constant is x minus 1 times x minus 2. Okay, so x minus 2's cancel, leaving me with 5x times x minus 1. So, and that's a minus in between. So minus 5x times x minus 1. Cool. And then finally, this last guy here, we're going to multiply by x minus 1 times x minus 2. The x minus 1s cancel. The x minus 2s cancel. Cancels the entire denominator out, which is lovely, leaving me with 2. Booyah. Okay, now we go back to little algebra 2. Let's simplify. So over on the left side, we got 4x. We're going to multiply 4x by x minus 2. That's going to be 4x squared minus 8x. Oh, that's nice. I like that. Let's multiply minus 5x times x minus 1. So we've got, let's turn that one green again, minus 5x squared plus 5x. Okay, and that's going to equal 2. Okay, combine like terms on the left side because we got some. So 4x squared minus 5x squared is negative 1x squared. If you want to just write negative x squared, that's perfectly fine. For the x terms, minus 8x plus 5x is going to give you minus 3x equals 2. All right, I want to get 0 on one side. So I'm going to put everything on the right so that I can have a nice positive a. It doesn't really matter, but I do want a positive a. So I'm going to add x squared. I'm going to add 3x. So that's going to give me 0 on this side. This is going to be positive x squared plus 3x plus 2. Well, this looks kind of familiar. Looks a lot like the previous question now. Just different sign. So we got 0 equals, okay, product sum. Product is positive 2. Well, it's got to be 1 times 2. The middle is a positive number. So we're going to add up to positive 3, multiply to positive 2. Looks like plus 1 times plus 2. Cool. All right. So x plus 1 could be 0. X plus 2 could be 0. So here x is negative 1, x is negative 2. Okay. So we've isolated the variable. Next thing we're going to do is we're going to go back to the beginning, look at the denominators, and we're going to look and see what can x not equal. Okay. What could x not equal? Well, for x minus 1, if x minus 1 equals 0, or it doesn't equal 0, because that's a denominator, we got to say the denominator can't equal 0, then we know that x can't be positive 1. Okay, well, that's not either one of these guys. For x minus 2, if x minus 2 can't be 0, then x can't be 2. Well, that's not either one of these guys either, because these guys are negative. So looks like both of these answers should be solutions to our original question. Okay, so with that in mind, let's look at Desmos and see if we can graph it. Okay, so here is our graph. Again, I set my equation equal to 0 by subtracting the 2 over x squared minus 3x plus 2. And it does look like I've got myself a couple of zeros right there. Okay? So negative 1 and negative 2 are zeros. If I zoom in a little bit further, you can see that there's your 0 at negative 2, then it pops up above the x-axis and then comes back down to negative 1. Okay? All right. So let's go back and sketch it. Okay. So let's see. So it came along under here. And it did this. It went there. And there was a little break. And it went up a little bit. Okay. So this was my negative 2. This was my negative 1. And there's my basic sketch. Okay. All right. Let's look at our last question here. Now this one looks almost too kind. So there's got to be something up with this. Okay. It can't be this kind because look at the denominators. What do we got for denominators? You got x. Well, I guess that's my LCD. That's pretty simple for step 1. Okay, now let's get our x isolated by multiplying all of these terms by x. So we got 1 term, 2 term, 3 term, 4 terms we're going to multiply by x. So multiply the first term by x, I just get 12. I multiply the second term by x, I get x times x, which is x squared. I multiply the third term by x, I got minus 8x. I multiply the 1 by x and I get x. Sweet. Okay, so let's get everything on one side of the equal sign. Since the positive x squared is there, I'm going to subtract x both sides. Let's just keep it in the same order for now. Negative 8x minus 1x is negative 9x. Okay. Let's arrange it so that my A, my B, my C are in that order, descending order. So x to the second, x to the first, x to the 0. Okay. Now, let's see. Product, sum. Product is positive 12, sum is negative 9. Okay, what are the factors of 12? 1 times 12, 2 times 6, 3 times 4. Can any of these combinations, adding or subtracting, give you a 9? No. That's where the catch comes in. It was easy to get here. Now this is not factorable. So that means that we have to use our good friend, the quadratic formula. So my A is 1, my B is negative 9, my C is positive 12. So since I've got this quadratic equal to 0, I can set up the quadratic formula. So x equals the opposite of B, which is positive 9, plus or minus the square root of B squared minus 4 times A, which is 1, times C, which is 12, all over 2 times A. Okay. Let's just go ahead and let's simplify this guy here. We know it's not going to be a nice perfect square, because if it were a perfect square, we could have factored it, and we couldn't factor it. So 9 plus or minus, let's see, 9 squared is 81, minus 4 times 12, that's 81 minus 48 is 33. And that's over 2. Okay, so what are these two zeros? We got 9 plus root 33 over 2. Okay, I'm taking the liberty of checking that out. Calculator says it's approximately 7.37. And then 9 minus root 33 over 2 is approximately 1.63. Okay. Now, we've isolated the x. We solved for x. Check to see if anything's extraneous. Well, it looks like the only thing that x could not be is 0. Right? The only denominator was x, and we know that the denominator can't equal 0. Well, this isn't 0, and this isn't 0. So I guess we're in luck there. So let's go to Desmos and see if we can verify this. Okay, over in Desmos, I've got this last one typed in. Let's check him out. Okay, so what do we see? Well, I can see 2 zeros here. I can see one here and one here. Okay, so the overall shape of the graph, oh, you got nice graph here, okay? So you have a couple of little intervals here in the lower left. In quadrant 3, it's got a nice little slant asymptote. And in quadrant 1, you got a nice little slant asymptote. So the only zeros I see are right here. And let's see if they look familiar. Well, look at that. 1.628, which we could round to 1.63, which was our 9 minus root 33 all over 2. And then 7.372, 7.37 is what we estimated for 9 plus root 33 over 2. So let's sketch this, if we could. Okay, so we had a slant asymptote. Okay. So the zeros that we wanted, 1.63, 7.37. Okay, those are our zeros. That's our solution. Okay, so yes, if you have a calculator, you can go right back there at the very beginning and do what we did at the end, but you do need to show all your steps without calculator, be able to verbally walk your way through it as well as writing it out. Okay, those 4 questions are done. Okay, day 2 for 2B or not to be. See ya.